Mr. the Frog, I suggest you get a tutor.
To find the derivative of y equals sine of 3x plus 1, first you take dy dx will equal the outside, which is cos, and then the of 3x plus 1, and then the inside, which would be 3. To find the derivative of sine to the negative fifth x minus cosine 3 to the x, you take dy dx will equal negative 5 sine to the negative 6x times the inside, which it would be cos of x, times the inside of that will just be 1, plus the second part, which will be negative 3 cos squared of x, times the inside, which will be negative sine of x times 1, which will simplify to dy dx equals negative 5 sine to the negative 6 of x times cosine of x plus 3 cos squared of x times sine of x. Okay, for this problem, we're trying to find f of g prime at x equals 1. So first you'll take the derivative of f of u, which will be 5u to the fourth plus 0. And then you take the derivative of g of x, which will be x over 2 to the negative 1 half. And then you're going to take your f of u and plug g of x in for u. So f of x to the negative 1 half over 2 to the fourth. And then that simplified will be 5x to the negative 2 over 2. Then you're going to plug in 1 for that. So 5 times 1 to the negative 2 over 2, which simplifies to 5 halves.
To find dy dx using implicit differentiation with the equation y squared equals x minus 1 over x plus 1, first you take the derivative of both sides so that you get 2y prime equals, and then on this side you use the quotient rule to get x plus 1 times 1 minus x minus 1 times 1 over x plus 1 squared. Next you end up transferring the negative to both sides of the equation to simplify. Now continue to keep simplifying. So now you're able to take out an x, and you are able to get 2y prime equals 2 over x plus 1 squared. Now you're able to divide the 2y prime by 2y. So y prime equals 2 over 2y times x plus 1 squared. using implicit differentiation to find dy dx, then 2dy 2dx for the equation x squared plus y squared equals 1. And first you start by taking the derivative, so you get 2x plus 2y dy dx equals 0. Now you're able to subtract 2x from the equation, and to move it to the other side. Now you're able to divide by 2y so that you're able to find the first derivative. By simplifying, you're able to get negative x over y for your first derivative. And now you take a second derivative to be able to find. Now you start by taking the second derivative, so you get by using the quotient rule, you're able to get y times 1 minus x times y prime over y squared. And now, since you already know what y prime is, you're able to put that back into the equation and making it y times x times negative x over y squared. Now you're able to simplify a bit more, or getting the equation and 2dy 2dx equals negative y plus x squared over y squared. Now you multiply y to the top and bottom to be able to get rid of the denominator in this problem. So your equation that you finish with is y squared plus x squared over y cubed, and after simplifying a little bit more, you get at 2dy 2dx equals also negative 1 over y cubed. To find the tangent line and the normal line to the curve at the given point, and with the equation 2xy plus pi sine of y equals 2 pi times 1 pi over 2. First, you take the derivative of the equation using implicit differentiation, and you start by taking the product rule of 2xy, so you get 2xy prime plus y times 1 plus pi cosine of y prime equals 0. Well, next you distribute the 2 to the xy prime plus y, so you get 2xy prime plus 2y plus pi cosine of y times y prime equals 0. Now you're able to subtract the 2y from the equation. Now you have 2xy prime plus pi cosine of y times y prime equals negative 2y. Now you're able to pull a y prime from the equation. So you get y prime times 2x plus pi cosine of y equals negative 2y. Now you can divide this so you get y prime alone on one side. I'd given you the equation y prime equals negative 2y over 2x plus pi cosine of y. Now you're able to start plugging in the points that you were given, and you get y prime equals negative 2 times pi over 2 over 2 times 1 and plus pi cosine of pi over 2. Now you have y prime equals also pi over 2 plus pi times 0. So the slope of your tangent line is y prime equals pi over 2, and you're able to plug in point slope equation so that you can get to the tangent line is y minus pi over 2 equals I'm sorry, I forgot to keep the negative, equals negative pi over 2 times x minus 1, and the normal line is y minus pi over 2 equals 2 over pi times x minus 1.
Okay, for this example, we need to find the derivative of y with respect to t with the given equation of y equals the inverse sine of root 2 times t. So to take the derivative of the inverse sine, you need to know that y prime will be equal to u prime over root 1 minus u squared. So now we can take the derivative. It will be y prime is equal to root 2 over the root of 1 minus 2t.
Go.
Okay, for this example, we need to find an equation for the line tangent to the graph of y equals the tangent of x at the point pi over 4 and 1. First, we should take the derivative of tangent of x, which will give us secant squared of x. Now we want to plug in our x value, which will give us y prime is equal to the secant squared of pi over 4, which simplifies down to 2. This is now our slope. So we can plug this into the point slope equation, which is y minus 1, which is going to equal 2 parenthesis x minus pi over 4, which then simplifies to the y equals 2x minus pi over 4 plus 1.
Go.
Okay, in this example, we need to find an equation for the line tangent to the graph of the y equals inverse tangent of x at the point 1 comma pi over 4. So we need to take the derivative of the inverse tangent. So to do that, we need to know that the derivative is equal to u prime over 1 plus u squared. So it is y prime is equal to 1 over 1 plus x squared, which now if we substitute 1 in for x, we have y prime is equal to 1 over 1 plus 1 squared, which is equal to y prime is equal to 1 over 2. And now that we have our slope, we can plug it into the point slope equation. Y minus pi over 4 is equal to 1/2 x minus 1. And if you multiply the 1/2 into the quantity, you have y minus pi over 4 equals 1/2 x minus 1/2. Then add the pi over 4, y equals 1/2 x minus 1/2 plus pi over 4. Okay, go. Okay, in this last example, we have to find the derivative of y with respect to x with a given equation of y equals the inverse cosine of x squared. Well, to find the derivative of inverse cosine, you need to know that the inverse cosine will equal negative u prime over square root 1 minus u squared. So, knowing this, you can now substitute in some numbers. So y prime will equal 2x, negative 2x, over the square root of 1 minus x squared, which simplifies down to y prime equals negative 2x over the square root of 1 minus x to the 4th.
Alright, to find dy dx for y equals e to the negative x, you take dy dx will equal e to the negative x times by the derivative of the power, which will be negative x, which is negative 1. So then dy dx equals negative e to the negative x.
In this example, we need to find dy dx with a given equation of y equals the natural log of 1 over x. So to find the derivative of natural log, we need to know that natural log is equal to u prime over u. Now we can take the derivative. So y prime will equal, first we should bring x to the numerator, so x is equal to negative 1 times 1. Then we take the derivative. So y prime equals negative 1 times x to the negative second over x to the negative first. Now, knowing that this is x to the negative first, you can bring it up. So y prime will equal negative x to the negative second times x, which y prime will then equal negative x over x squared, which simplifies to y prime equals 1 over negative x.
Radioactive decay. The amount A in grams of radioactive plutonium remains in a 20-gram sample after T days is given by the formula A equals 20 times 1/2 to the T over 140. At what rate is the plutonium decaying when T equals 2 days? First, you need to start by taking a derivative, so you get A prime equals 20 times, and the derivative of a constant to a power is would make this 1/2 to the T over 140 times the natural log of 1/2 times 1 over 140. Now at this point you're able to start plugging in your T equals 2 days, so you get A prime equals 20 times 1/2 to the 2 over 140 natural log of 1/2 times 1 over 140. And now if you plug all of this into your calculator, you get A prime equals negative 0.098 grams per day. So this means that the amount of plutonium is decreasing at a rate of 0.098 grams per day.